All right, guys, today we're talking about special right triangles. I hope you guys pay attention to this because this is day 1 of 2 of this. Today we're talking about specific special right triangles. They're called 45, 45, 90 right triangles. All the triangles that we are dealing with will be right triangles. They will all have 45 degrees in one corner, 45 degrees in another corner, and 90 degrees in the other corner. That's why they're called 45, 45, 90 triangles. Does that make sense? Okay? And what we're going to do is we're going to learn a process, one process, which will help us to decipher sort of what those side lengths are. It's kind of a shortcut. We could just use the Pythagorean theorem every single time. We could, but there's actually a shortcut involved. So this is sort of teaching a shortcut. It's not necessary, but it's a shortcut in case you come upon these, okay? And they actually come up quite often in mathematics. So that's one reason we're talking about it, okay? Because the interior angles of an isosceles triangle are 45, 45, and 90, they're called 45, 45, 90 triangles, okay? Because each isosceles right triangle is half a square, okay? So on your picture, there's actually like a little dotted line up here. I don't know where mine went. But basically, this is, oh, you don't have it yet. That's great. I'll pass it out to you guys. But you guys can see this, right? It's half a square, okay? It's half of a square. So these triangles show up often in mathematics and in engineering. So these happen often. I'm just trying to tell you they do happen often, okay? What I want you guys to do is I want you to actually, for these very first 3 problems, which you'll get your sheet very soon, not that you couldn't take notes on your own, but you're going to actually find the length of the hypotenuse for each one of these triangles. And what I want you to do is I want you to find the exact length, okay? So don't do any decimals, but what I want you to do is I want you to simplify your radicals all the way. Is that okay? Faux sha. Okay? So please take care of this. I'll give you guys about 30 seconds because it should not take you very long to do this once you have them, once everybody has them, to do these, because you guys have been getting really, really good at using the Pythagorean theorem to find side lengths. Thanks. No, you need to grade it another time at an appropriate time. Yeah, don't lose it, and don't forget to turn it in. Okay, guys. Hopefully everybody has a sheet now. You probably could have finished it in the time it took me to pass these out. But you guys, including everyone, you are working on this, finding the length of the hypotenuse isosceles right triangle. You guys are hopefully doing this on your own without having to watch me for this. And we did talk about this. It was I think it was sometime last week, probably like Monday or Tuesday-ish. We actually talked about this concept of how to figure these out, and there's a really nice shortcut. Does anyone need more time? Okay. Why don't you check yours with me really fast? Number 1, your side lengths were 1 and 1, and your hypotenuse was 1 times the square root of 2. Generally speaking, we wouldn't write this 1 here. I'm writing it there kind of to show you something really fast. These side lengths were what? 2 and 2, and your hypotenuse turned out to be 2 times the square root of 2. See that? These side lengths were 3 and 3, and your hypotenuse turned out to be fully simplified 3 times the square root of 2. Does that make sense? Do you guys notice a pattern? The fourth step. 1, 2. So you get everything but the actual part that makes the pattern. Do you not know how to get it? So you don't know how to get from the square root of 8 to make this 4 and 2 and 2 and 2, pair of 2's, square root of 2. It's 1 times the square root of 2. I just simplified it. Simplified a radical. Can you break 8 down? Yeah. Can you break 18 down? Yeah, it's 9 and 2, and that's 3 and 3. So it's 3 square root of 2. Is that okay? Okay, so someone tell me the pattern. Please.
The two legs
are equal, because it's not an isosceles triangle.
So that's the whole number.
Uh-huh.
And then
it's always square root of 2. That's exactly it. So if we were to fill this one out, we would say this would be 1 times the square root of 2. If we were to fill this out, it would be 2 times the square root of 2. If we fill this one out, it would be 3 times the square root of 3. This is, guess what, 4 times the square root, I'm sorry, these are all square root of 2's. This is 5 times the square root of 2. What's the next one? 6 times the square root of 2. What's the one with the 7's? Very good. Mitchell? What's the one with the 10? 10 times the square root of 2. If you say to the, it means that it's going to be an exponent, and you'll get into that probably about 2 years when you're taking algebra 2, if you take it. Now, this is kind of the weird part. If the side lengths of the leg are just L, it says L, then we would have to say this is L times the square root of 2. Okay? So whatever the side length of the leg is times the square root of 2 is going to give you your hypotenuse. In summary, it says in an isosceles right triangle, if the legs have a length of, we'll just say L, then the hypotenuse has a length of L times the square root of 2. Does everyone understand this? I would put a star next to this, because if someone has some problems about this, they could probably come back in their notes to this point, and they wouldn't have to ask questions inside a class that are really redundant. But that's it. No offense. Questions at inappropriate times are bad. I agree. Thank you. This is an isosceles right triangle, so that's 14, 14. What's A going to equal? 14 times the square root of 2. This is awesome. Number 2, this is 72. It's an isosceles right triangle, so that's 72 and 72. What's A going to equal? 72 times the square root of 2. That's awesome. Number 3, a little bit different. This is B, so this is B. So we have to say B is going to equal, well, we just basically take that number from there, right? We have to say that L times the square root of 2 is going to equal 13 times the square root of 2, like that. I'm doing this because we're going to use this same mentality later on. This is the formula for the hypotenuse, and that's the length of our hypotenuse. All we'll do is we'll divide both sides by the square root of 2, and L equals 13. That's probably the easy part, or I guess B equals 13. Okay? So B equals 13. So if this is 13, this is 13, this would have to be 13 times the square root of 2. Does that make sense, Nicole? You're not Nicole. Does that make sense? Okay. Number 5. Number 4, I guess. Number 4, since these are 45, 45, 90 triangles, you know they're already Brandy. This is warning number 2. Number 3, you guys are separated forever. Since these are 45, 45, 90 triangles, you automatically know, since these side lengths are the same, that since these angles are the same, that the side lengths will be the same. So this is 4 and this is 4. What does x have to equal? 4 times the square root of 2. That's right. Okay? Not all of them are going to be this simple, but we're getting through all the easy ones right now. So this is 6, this is 6. What does x have to equal? 6 times the square root of 2. Oh man, look at that. That's what happens when people plant bad negative seeds. They start growing in other people's minds. Number 6. Number 6. Is this a 45, 45, 90 triangle? How do you know? Okay, because these two side lengths are the same. That means that these two angles are going to be the same, and we could figure this out using the triangle sum theorem, that those two would be 45 degrees. Okay, so what does x have to equal? 5 times the square root of 2. That's good. Number 7, this has to be x down here. So x, remember that we know the hypotenuse, so we're going to write this down. We're going to say L times the square root of 2 has to equal 3 times the square root of 2. We'll divide both sides by the square root of 2. Those will cancel. And L, or I guess x, that length, is going to equal 3. Okay, I'm just showing you algebraically how to do this correctly as we go along. Any questions up through 7? Okay, no, sir. Okay. Number 8. What does x have to equal? It's going to equal 9. Hopefully you guys are seeing sort of shortcut that you can basically get rid of that square root of 2, or you're dividing by the square root of 2. Number 9 is a little different though, right? Okay. Because over here we would have basically said that, you know, L times the square root of 2 has to equal 9 times the square root of 2. We divide both sides by the square root of 2, and L in this case equals 9, like we just said. But over here, number 9 is a little bit different because it doesn't have a square root of 2 in the problem, does it? Okay? We still say the same thing, though, like L times the square root of 2 equals 2. We divide both sides by the square root of 2, and L, or x, I guess in this case, has to equal 2 divided by the square root of 2. Mathematically, later on, you'll realize that you're not supposed to write this way, but we don't learn that right now. That's not a proper way of writing that. But that, for right now, I guess that's fine. 2 divided by the square root of 2. Okay, so it is a fraction. Okay, same thing here. If we have 12, we would just say 12 equals L times the square root of 2. We divide both sides by the square root of 2. That cancels. And our length, or x, equals 12 divided by the square root of 2. Why don't you guys try number 11 on your own? Try number 11 on your own. Seems to me that it's kind of a nice shortcut to have in order to try figuring out the side lengths. Instead of having to always use the Pythagorean theorem and set this up the long way, this is what it would look like the long way, is if you said this is, hey, this is x squared plus x squared equals 22 squared. You gotta say, well, that's 2x squared equals, let's see, 22 squared, is that 440, maybe? I don't know if that's right. What's 22 squared? 484? Okay, we would divide both sides by 2, and that would equal 242. You'd have to take the square root of that. This would be a mess. 242, and we'd probably get some crazy answer. And it would work. What's that? 11 square root of 2? Okay, this is the long way. It's the long way. It's not the way that I would do this. And it just seems that the things that we're doing seem to take a lot less work. All we have to do here is to say that L times the square root of 2 equals 22. We divide both sides by the square root of 2, and all of a sudden our answer, L, or I guess x in this case, will equal 22 divided by the square root of 2. And these two, if you were to put them in your calculator, do give you the exact same answer. Later on, when we start doing trig, I'll show you how to write this a little bit differently. So we will do this. Okay. Trigonometry is basically the study of triangles and triangle lengths. So it's very similar to the things that we've talked about so far, but they'll just go one step further. Okay. Relationships between angles and sides. Any questions on how this works? Okay. Tomorrow, just to give you a little scope of what we're doing tomorrow, we're going to work on 30, 60, 90 triangles. Okay. What's really nice about the 45, 45, 90s is there's basically just one relationship between side lengths. Because these sides are always going to be the same, the x and the x are always going to be the same. There's only one relationship. Tomorrow is going to be a little bit more taxing because there's actually 3 separate relationships that go on. So depending on what side length you're given is going to determine kind of what we do for the next couple steps. So today's the easy day. Tomorrow's going to be a little bit more complicated.